Assalamu alaikum and hi, welcome back to 1.4.4 volume of a solid of revolution. This is the last part of chapter 1. Now we are going to learn how to find the volume of a solid produced by revolving the region between two curves. So basically, if we have two curves that intersect with each other, and there is a region between them that is revolved about the x or the y axis, so we can find the volume. Okay, so when it is revolved around the x-axis, this is what happens. So we're going to use the same formula, and as usual we will take the one on the upper side minus the one on the lower side, and for the y-axis we take the one on the right hand side minus the one on the left hand side. So now we're going to try example 13, question number 1. Find the volume of the solid of revolution formed by revolving the region bounded by 2y equals x plus 3 and y equals 2x minus 4 through the x-axis. I'm sorry, there's a typo here. The graph should be y squared equals 4x. So as we can see in the diagram, y squared actually sits on the upper side. Okay, so y squared equals 4x is on the upper side of 2y equals x plus 3. So before we can proceed, we need to find the points of intersection by solving the equation simultaneously. Okay, so we have 2y equals x plus 3 as equation number 1, and y squared equals 4x as equation number 2. Okay, so from equation 1 we have y equals x plus 3 over 2, and substitute that into equation 2. We get x plus 3 over 2 squared is equal to 4x. And then expand that, we get x plus 3 squared equals, so 2 to the power of 2 is 4, so 4 times 4x is 16x. So now we have x squared plus 6x plus 9 equals 16x. So finally we have x squared minus 10x plus 9 is equal to 0, and then factorize, we get 9, 1, negative, so x is equal to 1, x is equal to 9. So we know that the boundaries are 1 and 9. Okay, and then after that we need to express y squared in terms of x for both graphs. We already have y squared in terms of x for the curve, so now we need to express the straight line, okay, for 2y equals x plus 3. We want to express that in the form y squared in the form of x. Y is equal to 1 over 2 times x plus 3. So y squared is equal to 1 over 4 times x squared plus 6x plus 9. So putting them together, we have v equals pi times the integration from 1 to 9 of 4x minus 1 over 4 times x squared plus 6x plus 9 and dx. So in order to simplify that, we take out 1 over 4, so we have pi over 4 on the outside and 4x becomes 16x minus x squared minus 6 squared minus 9 dx. And then rearrange that first. We get negative x squared plus 10x minus 9. Okay, and then integrate as usual. So we have negative x cubed over 3 plus 5x squared minus 9x. The boundary is from 1 to 9. Okay, and then that is equal to pi over 4. So first substitute 9. Negative 243 plus 81 times 5, so 405 minus 81. And then for the second one, it's negative 1 over 3 plus 5 minus 9. So we have pi over 4 times 81 minus negative 13 over 3. And finally we have pi over 4 times 256 over 3, and hence the volume is 64 over 3 unit cube. Now the final question, final example for chapter 1. Example 13, question 2. Find the volume of the solid of revolution generated when the region bounded by y squared equals 4x, the curve here, and y equals 2x minus 4, the straight line here, is revolved about the y-axis. So before we can integrate, we need to find the boundaries, which can be found using by solving both equations simultaneously. So now we have the first equation as y squared equals 4x, and the second one y equals 2x minus 4. Okay, and then from equation 1 we have x equals y squared over 4, and then substitute that into equation 2. We get y equals 2 times y squared over 4 minus 4, and multiply both sides with 4. We get 4y equals 2y squared minus 16, and then put everything on one side. 2y squared minus minus 4y minus 16 equals 0. Simplify y squared minus 2y minus 8 equals 0. And then factorize for 2. So negative 4 plus 2. Therefore y is equal to negative 2. Y is equal to 4. So the one at the bottom here is negative 2, and the one at the top is 4. So now we have the boundaries for our integration. Then we can proceed with the integration. But before that, we need to express x squared in terms of y. Okay, so for y squared equals 4x, so x is equal to y squared over 4. X squared is equal to y to the power of 4 over 16. And for the other one, for y equals 2x minus 4, x is equal to y plus 4 over 2. So x squared is equal to y squared plus 8y plus 16 over 4. and put that in one integral. We have v equals the integration from negative 2 to 4 times pi of first the straight line, which is y squared plus 8y plus 16 over 4 minus y to the power of 4 over 16 dy, and then integrate that as usual. We get y to the power of 3 over 12 plus y squared plus 4y minus y to the power of 5 over 80 from negative 2 to 4, and then substitute the boundaries into the integral. So we have 16 over 3 plus 16 plus 16 minus 64 over 5 bracket and minus negative 2 over 3 plus 4 minus 8 plus 2 over 5 close the bracket, and then we have pi times 368 over 15 plus 64 over 15, and finally we have v equals 144 over 5 pi unit cube. So that's all for chapter 1. I hope the videos help you in understanding integration better, and so that you are able to solve the tutorial questions. And that's all. Sekian, terima kasih.